And you're looking up negative 0.8 over to the 8, and it's 0.1894. So there's the first two. Raise your hand if you're feeling good so far.
Why would we round the wrong beat?
Because if I look for 0.875 negative, right? So I go to negative 0.8. Negative 0.87 would be the closest we could get, but that would just be by cutting off the 5, because there's not a third decimal place option. So that's why we had to round it. And then we have our next one, which we called 2B. So we had 1A, 1B, area shaded to the left, and then 2A, 2A, and 2B. So 2A, when you found negative 2.01, that's where we had to round again. You should have gotten 0.222, which you subtract from 1 and get 0.9778.
I have a question. Can't you just do like the opposite? Like look at the just 2.01, it gives you the same answer instead of subtracting.
You looked at the,
Like instead of looking at negative 2.01, I looked at 2.01 and it gives you that answer.
mm-hmm.
Because I accidentally did that and then I like went back and I thought I got it wrong and then I gave you the same one.
Yes. If you can keep track of that in your head. But just in terms of logically what I can picture, you know, it makes a little more sense to just subtract from 1, but you're right. And then 2B, we've got the 0.8997. And that represents the area to the left of 1.28, so we subtract from 1 and we get 0.1003. Good? Okay, and then last row here, 3A, so we have the two z-scores. So we look both of those up to find the area. Subtract larger minus smaller, we get 0.6826, which should sound familiar since we're talking about exactly one standard deviation in both directions away from the mean, which we would expect to find what percent of the data there? 68%, and there you have it, 68%. And you can see where we even round in the empirical rule a little bit. This is a little more exact than we talk about in the empirical rule. And then last one, you've got the 0.5 here in the middle. We know if it's right in the middle, it's representing half of the area to the left. So it's also represented in our table. And then to the left of 1.54, we get 0.9382, and then subtract and get that final area of 0.4382. Questions? All right. So then for the next section, we're only going to do the odds. So I want you to do 7, 9, 11, and 13. And this is the first section where you actually do need to sketch the graph. So it's my expectation that you're sketching the graph like step 1 indicates. So you'll actually draw out your x-axis there. Draw the normal curve. Put the 0 in the middle. I like to put my 3 marks above and below just to give me a reference for my 1, 2, 3, negative 1, 2, 3. Find the given z-score, so 1.35. And then shade the region indicated. Since it says z is less than 1.35, we shade to the left. Sorry, I should write 1.35 there. and then calculate that. Or sorry, find that on the table. So find 1.35. And write down that area. And then number 9. So this time we're talking about a z-score greater than 2.358, which we're going to round to 2.36. And we're just talking about to the right, greater than this time, so I'm going to shade this little section. I need to look that up on my z-score table. 2.36. And then, since it's to the right, we have to subtract that from 1. So 1 minus whatever value you find on that table.
So whenever it says to the right, you can subtract.
When it says to the right of a given z-score, you're subtracting that number from 1. And then number 11, negative 0.89. So between negative 0.89 and 0, that's like our third type, where we have to find both and subtract. Number 13 is the same way.